Hey guys, welcome back to another episode of Craft Beer and Data. My name is Nick Piette, Chief Evangelist here at Talend.
I'm Mark Balkenende, Director of Technical Product Marketing at Talend.
And we know it's been a while. It's been about a month since we put one of these things together, but we had a really great event at Talend Connect.
Yep.
And so we're kind of getting back on the road. We're on the, fourth city of the Thinking While Drinking tour.
I thought that wasn't sanctioned.
Sorry, the TWD.
Okay.
All right, I'm going to continue.
Hashtag TWD.
Hashtag TWD.
It's my next t-shirt.
All right, exactly.
Creation.
So last time you saw us, we were in Nashville at New Heights Brewery. This time we are here in St. Louis.
Sunny, humid St. Louis.
At Urban Chestnut Brewery, right? It's a great place. It's been fun kind of walking around here. Massive facility.
Huge.
Great place to go for a beer. So
I'm not sure they still qualify as a microbrewery.
Yeah, exactly. But we're going to go a little OG this week. We unfortunately weren't able to get a brewer this time, so we're going to just dive right into the technologies.
Absolutely.
And
the fun stuff anyway, right?
Yeah, exactly. So let's hit some of the buzzwords of the last couple months.
You do the buzzwords.
Right. Microservices, containerization, and serverless. I think it'll be a good episode. It was really some of the highly watched and viewed sessions we had from Talend Connect.
Yes.
So clearly there's a lot of interest in the subject, so why don't we kick it off?
The fun part, we had one of our keynote speakers was Steve Sine from the CEO of Docker, and he's on the talent board. So he was up with our CEO, Mike Tukin, talking about containerization and what he feels is careful.
I know, right?
Let's not knock us off the stools here.
It's made of wood, real sturdy.
That is, not your chair. I'm not worried about the beers, Nick. I'm worried about us. But Steve was telling, he was talking, had a lot of great insights around containerization, microservices, and told a little story about how the whole concepts around containers, and I really liked how he talked about shipping in the early days, where everything was all different sizes and wouldn't fit on trucks, and you couldn't stack them on the ships, and when they came up with those containers that you see on the big massive ships that go overseas, it really revolutionized shipping across the board, because not only could you start, put more stuff on ships coming across the oceans, but you could then take that exact container off the ship, put it on a truck or on a train, and it would fit everything everywhere. Yeah. And you really commoditized shipping at that point, and it became much cheaper for things from, making shipping more global. And that really is, the basis, the same concept or the same thought process is what's behind containers and containerization, which then leads to serverless, which we'll talk about, which isn't really serverless. Yeah, which
isn't.
There really is a server back there. It's not
the fine print.
Pixie dust running.
Sprinkle
something.
You're gonna do the salt hand? No, Mark, we don't do that on the show. No, so you hit it dead on. It's interesting to kind of talk about that from look how organizations are taking advantage of this. And really one of the big questions that kind of came out of this is, look, yes, containers sound like a great way of trying to work with new ways of deploying these technologies. But that doesn't necessarily mean like what I have today, I can just roll over and put it in a container and hey, the world's saved, right? And it leads really into that kind of that first topic of microservices. What is it? What is it? How does it? What do I need to do with it? How do I actually deploy it? It's fun as we've been kind of going through this. And really, when we look at microservices, we kind of look at it more of like an architectural design, right? Where you had these monolithic applications in the past, and either through a maintenance or trying to create upgrades, you start to realize that over time, as the application grows organically, the time it takes to actually try to update or keep this thing going is just, it's not feasible from an economic standpoint. And so we have to kind of look at how can we break these things down into kind of more consumable parts. It's kind of interesting. We were talking with one of our customers who had gone through this journey of this decomposition, if you will, of their existing application. And the best way I can kind of relate it is just like taking an old car engine, breaking it apart, tying it all together with tubes, and then getting it to run again. right? In doing so in a way that's more cost effective than just putting it back together in this big application and running it. And so, it breaks up into a couple pieces, and how you want to decompose these applications. The two main pieces I've seen when we're doing the research is kind of what they're calling noun-based or verb-based decomposition. And it's really fascinating to see just how and why enterprises are breaking their applications into those kind of pieces. Once they've kind of identified the architectural requirements, they've built the applications, that's when we can start talking about like containers and really like either containers as a service or some of these functions as a service that we're seeing a lot come up too.
Right, and a lot of the architectural patterns that you're seeing in this microservice environment is very similar to the old SOA patterns and practices, and breaking your applications up into services as an architecture. So it's really a lot of the same patterns just being implemented in a slightly different way that becomes more agnostic of the environment in which those services are running. The microservices are more self-contained, I believe, and it's maybe the way you want to say it, maybe not the right way. It's the way I'm saying it after a beer or two. And I am in training for a race,
That's
so
true.
Nick will most likely outdrink me today because I'm not drinking heavily.
This is why we can't do a big
my disclaimer.
Yeah, right. Exactly.
So, but yeah, I mean, it's looking at something that we've been trying to solve, I think, in the software and application space for a long time. And there's a lot of things that I think SOA didn't really deliver, that the microservices trend, or however you want to call it, really is addressing, like you said. So it's taking that noun and the verb and really breaking them down into microservices, into a very small service that can really stand on its own, run on its own, nonstop. In an environment which may be a container,
right,
or it may be some type of OSGI or some type of other service container that's wrapped around it, but it literally stands on its own. It can run independently. If other services go down around it, it doesn't hurt it, so you can continually upgrade your applications and do things like that. So.
Yeah, well, and it speaks to kind of that mindset of how do I decompose an application into something that actually makes sense. And so the best way that I could relate to it when I was doing the research, when we look at noun-based or verb-based decompositions, the easiest one is probably the verb-based, right?
Do I write a sentence with that? Or?
Yeah, exactly. Well, I mean, think about it, like the action, right?
So, yes. Like, I'm joking.
Yeah, well,
it's an English grammar joke. Never mind. Go. Yeah, over your head.
Sorry, bud.
Go back to your noun and verbs.
Yeah, it's true.
Are there adjectives or?
There's some proper nouns, and we'll get into what that looks like. No. So, I mean, when you think about it in terms of the action, like maybe like get ID or go check, like a basic check, in the way that we can wrap those, even the tiniest services, into a function as a service, which could be deployed on like AWS Lambda or Microsoft or Google's equivalent when it comes to those quick function runnables. And then you have the more, I'd say, traditional, longer running processes that are going to be more noun-based. And those are likely going to be the ones that are actually connecting to message queues, like Kafka or JMS. Whereas verb-based applications are probably most interacted through a REST API or something like that. So finding ways of really optimizing the application between those two layers to take advantage of, as we've been talking about, containers and then functions. So where this gets kind of interesting is when we apply this serverless component to it as well.
So what do you mean by server? There's no servers running?
Right. No, it's black magic, people. You pray to the machine god, and then you get the result. That's how it works, right?
You just put it in the cloud, man.
Just put it in the cloud.
No, it's all in the cloud.
It's all.
There's no servers up there.
Right, and of course servers are still there, right? I mean, it's
so there's a point of failure there. It's just not your concern that it fails.
Yeah, it's not. No, I mean,
is that the point, or of serverless?
No, I mean, I think as we look at it, kind of, and this is one of those probably more frequently used marketing buzzwords, but generally when
I'm in marketing,
so am I. Yeah, that's why we can make fun of ourselves, because we're part of that whole process. No, it's like we've come to the dark side. No, so when I look at serverless, I kind of look at the decoupling of, rather, when you were building applications in the past, you really had to take real concern with regards to, like, operating system? Or was that updated? Do I have the right patches in place? Do I have the right software in place? All those things at the end of the day, especially when this is really supposed to help support DevOps, which is 2018 shadow IT. God. That's
another buzzword.
That's another good story in itself.
Anyway.
Look, I want to develop code, right? And I want to be able to deploy this in a managed, scalable fashion. I don't necessarily care to understand the operating system at the level of detail that I likely need.
So you don't care if it's CentOS or
right,
or even AWS's version of Linux, or
Ubuntu
or Windows.
Yep, or Windows, right? I don't want to deal with that. So, but it's the idea.
What version of Windows?
Probably XP was my favorite. Yeah, I was alive back then, man. I saw XP.
Oh, that's amazing.
I know, right? It's just really this ability to not only not have to worry necessarily about the operating system, but really to recognize the economic shift that's occurring with regards to how these things are run. So as we are talking about some of those functions as a service, and even some containers that might be the half-life of them, how long they're going to run is very short. The ability to really scale on demand and really price out in seconds.
So let's talk about that scale on demand, right? So that's always been, there's a crack there. Don't put it.
I know, right? Yeah,
that's always been one of the things that the whole enterprise service bus and services in general has always kind of been this utopia of scaling, but it's always been kind of hard because you've been tied to the ESBs of the world.
Yeah,
or just the ESB, the buses, and the infrastructure that you've deployed in runtime. So the cool thing about this serverless and microservices movement,
serverless,
has really been all about the ability to scale on the cloud infrastructures. Meaning, I have a service that maybe it's get customer as an example. It just gets some basic customer information. It may call several other services, and on a regular day, it's maybe 5 or 6 instances of that service can handle my load. But if I put a marketing campaign out, or maybe it's Black Friday, the biggest shopping day of the year, and people are hammering on my website, you would have to go back to whoever your ESB vendor is and say, hey, I need to double my run times to handle all this stuff and more, pay my compute time. Versus, hey, I'm going to put this out in one of these container services environment, and as I need more, it's going to auto scale for me. I can just bring up more of these services and handle my workload as much as I need. Right?
Yeah,
and you mentioned Lambda and being able to, have functions in place to say, hey, the number of volume calls coming in is through the roof.
Right.
And you, as the customer of this environment, you don't really have to do much of anything. It's going to have the computing processing time to handle that, right?
Absolutely. Well,
and that's the dream.
It's
utopia.
Well, and it speaks to something that's very interesting from an economic standpoint. In the past, when purchasing software in general, I was limited by having to purchase for max capacity. And as we've seen with a number of our customers, and many of you are probably dealing with on a regular basis, max capacity is a worst case scenario. It's not something that you're going to hit 90.
It's Black Friday if you're in retail,
right?
Or
exactly.
Right?
But you have to have it. Whereas this transition to be more elastically scalable, I can start working on demand.
It's the definition of elastic.
Exactly. It's just, but again, because of the way that it's priced out, I don't have to buy 10 or 15 really expensive servers.
Right.
Right. It's crazy.
So that's one huge benefit that you can achieve in this type of world. So that's pretty cool.
Yeah. It's what we were talking with a customer of ours that recently, as part of their process, it's funny you mentioned the Black Friday e-commerce platform, because it's exactly what they did. And it was in an attempt to better personalize the experience on their website, seeing if the person that was on their website had already been classified in a particular category, and those checks could be done in milliseconds. I don't need a long-running process to do that.
No.
It's, if you look at how they decompose their application, at least 3/4 of the process they put in place were just easy functions.
Easy functions.
Just bam, bam, bam. And then, leave the more complex work when you actually have to do it. So it's really fascinating to see how customers, and really enterprises as a whole, are taking advantage of now microservices to define the architecture, containerization for more of the long-running processes, functions as a service to really set some of those immediate tasks in place to really just disrupt data economics as a whole.
So, so containerization is a whole nother interesting topic in itself, right? So, with containers, do we just take our monolithic application and shove it in a container and run it out on Kubernetes or something out there on one of the cloud? Is that what you mean by containerization?
No, I mean, to be fair,
is that what you're talking about?
20 of people will do that, and this is
and there's nothing wrong with that.
Yeah, exactly. Right.
You might have sensed some sarcasm there, but
I really enjoy the old wind-up clocks I have at home. The grandfather clock that I've had.
You have a cuckoo clock?
Yeah, it's true. Yeah, every time. Boop, boop.
My parents still have them.
Yeah, but I mean, everyone loves nostalgia. No,
yeah.
But what I mean by this is that, all joking aside, yes, of course there are some immediate benefits to be able to do that, but some of the cost analysis depends on the application. In our space, it doesn't make a lot of sense, and the reason for that is twofold. I mean, when looking at containerization, I think that it really only makes sense when you're as close to native as possible.
Right.
Right. As close to the code as you possibly can be. When you're using interpreted languages through a proprietary runtime and things like that, it's really difficult to see a lot of the benefit from those cost savings, largely because the container should be as close form-fitting as the application as possible. And when you have something that's really traditionally meant to be up 24/7, chances are from a cost benefit, you're probably better off with an EC2 instance. Right?
Yeah.
You're missing that. And the other side of it is, for the scale that you were talking about, it's a whole level of complexity when you have to try to get these applications to try to talk to each other to scale out. It just doesn't make sense.
However, I do see that for some more traditional applications, if you want to make your platform cloud ready, as people keep saying, I think you're going to have to figure out a way to break your applications up and deliver in a container type world, maybe not to the noun or verb level that you were talking about
paragraph.
before.
We'll go paragraph.
But maybe a paragraph level or a page level.
I want the beginning, middle, and end, right?
But it really is becoming the way to deliver software, whether it is a service, a function, or something, a microservice, or if you are taking your application and putting it into containers. So, but yeah, one of the things I was reading too was, today it's, in the world of applications, it's not how many features or functions necessarily you can give your users in a fast fashion, but it's also how many function features you can give your users without any downtime. So, the days of, hey, I'm taking your application down at midnight for an hour and do some maintenance once a week to add more features and functions in, those days are fast behind us. And that's one of the things that, I see containerization and microservices being a huge value for software and how we deliver software to our users today is it does give us that ability to absolutely do that.
Yeah, you just be like, we got the nines. How many nines?
How many nines?
Doesn't matter. We got the nines.
As long as our cloud has nines.
Yeah, right. We got
as long as the cloud has some nines, we're good.
It's absolutely right. The ability to continuously deploy, manage those update cycles without having to bring the system down is imperative, especially when we're talking about, we might joke, but and granted, you'd never deploy this right before Black Friday, but in those moments, right, where there is extremely important data that's pushing through, downtime is just death.
Crucial.
Yeah.
Crucially awful. Yeah, you just brought up the nines, which bring back horrible memories of some of my past jobs.
PTSD. I'm so sorry. So sorry.
It's actually some of those nines is what drove me into the software business and out of IT. And I think those viewers watching in the IT that support some 3, 4, maybe 5 nines, you'll know what I'm talking about. So,
yeah, absolutely.
5 nines, what a nightmare.
Right.
That's I think defined in seconds for the year of downtime.
Yeah,
if I remember right, there's obviously definitions of that, but this is where all these things are really coming from. And it's actually funny, I've been listening to how some people define their 5.9s for their application, and somebody was complaining about one of the big cloud vendors. I'm not going to name any names in case they're watching, but
hi guys.
The comment was the services weren't down; they were up. You just couldn't reach them because the network was down.
Right.
Does that classify as being up? I don't know. So it's always funny how people kind of play with those numbers and stuff. But but it is in reality that's where a lot of the containerization and microservices and all these aspects are coming into play. And yes, there are servers behind serverless, but you're dealing on cloud platforms like Amazon and Microsoft and Google that have endless, not endless, but a huge amount of server compute powers. So if they lose a server, there's many more to come.
Now,
right? So
we do have to bring up, and I know if we don't say this, Ed Ost will probably kill us. But we've joked in the past.
Calling out, man.
Calling out Ed. Now, so Ed, now I know if you watch this or not, because he'll ping me later. Yeah. If you think about it, though, we have talked about in general the development practices for microservices using containers or functions as a service. You don't necessarily need to care so much about the operating system. It does change the focus to take advantage of some of these things, and we'll talk about how in a second.
We will?
Yes, we will. I've got a full beer. I know. I'm trying, we got to fill content.
I'm slowing down. You're actually keeping up this time since I slowed down.
You wait, man, you wait. No, so as I was talking about, while you don't necessarily need to care so much about the operating system, in this new world where even in containers, you can have these dynamic spot instances where you can rent essentially at a minute's time. I think it's about a 2-minute timeout before they take it away from you. There is a new architectural design pattern they have to think about, which is a failover state, right?
Yeah.
If I'm going to really stretch the limit of how inexpensive I can make this process, and I really want to take advantage of those spot instances, there is some thought process behind, how do you build a fault-tolerant, resilient application that can handle failure? And that's something that we're really starting to work with our customers on. Really excited to see what potential that has. Both from the application as well as some of the complementary technologies.
Which, when you talk about spot instances on AWS, so those are instances that AWS has and nobody's using them.
Right.
So you can get them at a much more reduced cost, but the price of that cheaper instance is they can pull that away from you instantly, right? So, So if you were to start deploying on that type of model, one of the interesting things that made me think immediately of our newest partner, Qubole, who does provide Spark environments, and they do a lot of the configuration and management of your Spark environment, and now Talend works with that. But if you think about it, and what they allow you to do is say, hey, I want 75% of my Spark cluster to be on spot instances. That's a huge savings over a regular instance. So if you think about that model, that's great because you save money. The other cool thing, if you think about how Spark and how Hadoop and HDFS and everything that works underneath the background of Spark and the multi-redundancy across nodes, if you lose a node in your cluster, you really don't lose anything.
Right.
Maybe a little bit of performance. But at the end of the day, Qubole will handle another spot node coming up. It'll replicate the data because that's what Spark and Hadoop does, and it just automatically takes over. So maybe have a little bit of performance degradation if you lose a spot instance here or there. But at the end of the day, it's a huge cost savings, a great model, a great tool that takes advantage of not only the architecture of Spark and Hadoop, but also the cost savings of what Amazon provides in, say, their spot instances. So very cool architecture, very cool platform. Qubole, now we're working,
really excited to work with them.
work on Qubole now, so it's very cool.
Yeah, no,
exciting.
I mean, and you brought up a really good point, is that everything we've been talking about, might be construed as just general application integration, like how you're building your basic apps. But a lot of the concepts that we've been talking about will definitely, as we see, are very applicable even in the big data space. So, very good point.
What actually brought that up was the fault tolerant, right? It's just, Spark and Hadoop and that platform is fault tolerant, right? It's built on redundancy across nodes, so you automatically have that
like,
built in. So
it tastes like toothpaste. Sorry, but you're right. Yes, sorry, toothpaste. It just threw me for a loop.
Not Nick's favorite, apparently.
Not my favorite. So, all right. So we've talked about microservices. We've talked about containers. We've talked about serverless. We've talked about its applicability in both like traditional application as well as big data processing. I mean, I think we've got a well-encompassing episode with regards to some of these concepts. If there are more questions you guys have, obviously our YouTube, our Facebook page, great places to reach out to us. If there's topics that you're interested in, we're always looking for more. And I know our Talend sales team has been providing a couple, like the last one we did on blockchain. There were some questions about that. So feel free to reach out to us. Again, my name is Nick.
I'm Mark.
Thank you for another episode of Craft Beer and Data.
Cheers.
You finally got it, man.
I got it.